because I think this is a great topic. We're going to be going over examples of how to assign 3D models to your components. But in addition to that, we're actually going to be covering, if you don't mind sharing your screen, that way that's not blank, Jorge, if you don't mind. Really appreciate it. And also, I'm going to make you the host since there's a good chance I will have to leave soon.
And here we go.
Okay, give me 1 second. I think I have the YouTube stream almost finished. Okay. Thank you, Jorge. I greatly appreciate it. Thank you so much. Okay, and I will record the session as well. So I'll go ahead and start that now. Just to let you know, you're sharing your screen, George. Just to let you know, give you a heads up on that one. So in today's topic, we're going to be covering the different methods by which, well, first of all, thank you, and thank you for joining us, and welcome to Autodesk Eagle's webinar. And today we're going to be covering it's a very simple topic, but it's kind of key to your workflow when it comes to using Eagle. Actually, it key into anytime you're using electronic design CAD program anyway. So today is we want to give you the foundation that is necessary for you to have a successful electromechanical workflow between Eagle and Fusion 360. But in addition to that, earlier this summer, the capabilities were added. That way you could share your libraries by means of managed folders. That way you could actually share your libraries. See, we had library sharing, but you would lose your 3D models. Now with this new system that was added earlier this summer, not only you could share your libraries, but the 3D models will come along as well. Um, you you have full administration of who's actually going to be using your libraries, or who has access to your libraries, I should say. So Jorge is going to be driving that demonstration today. First of all, it's going to do some 3D mapping. So my name is Edwin Robledo. Um, I run, or I'm part of the Autodesk Eagle um, specialist support team. And with us today is Jorge Garcia, which is also a community manager, as well as a support specialist for Autodesk Eagle. So we're going to go ahead and start from Eagle itself directly. We're going to go live with Eagle. And then from that point, we're going to show you, we're going to be going over the library.io to show you how you do all of your administration and go back how that reflects under your account. So I'm going to go ahead and mute my microphone and allow Jorge to go ahead and begin the demonstration. It's 2 o'clock exactly. So we did just fine, George.
Awesome. So right now you're looking at a library that I've prepared for this webinar. Right now it just contains 2 footprints. These I got from built-in the ref packages library. We're only using them as a starting point. We're going to go ahead and create a symbol. We're going to add the 3D footprint, sorry, the 3D package, and we're going to add a device as well, connecting all of these together. So to start, if anybody needs it, we're going to be making this part, the TPS 92411. Okay, so if you want to look up the data sheet, I have a printout in front of me, so I'll be relying on that to speed things up. But this is the part we'll be making. And this is a good part because for the 3D aspects, we can exercise several different facilities that we have in Eagle. So we can use a package generator, we can assign one of the built-in models. So there's a few options here, and that's why I picked it. So let's go ahead and go back to Eagle. First thing we're going to do is we're going to make a symbol. Now this symbol, again, we'll just name it TPS 92411. We'll say, okay, yes, I do want to create it. What's nice about the symbols is just 5 pins, really, really simple. So you could go through the process of drawing everything out and putting in the name and value. But recently we added this pin array feature, which allows you to kind of in one go make everything. So we want to include greater than sign name and greater than sign value labels. We want to generate the rectangle around the symbol. The base name isn't important because we're going to basically change them all to be whatever the functions of the part are, but at least we'll have the pin seated, and then we can adjust from there. Left, right. We need 5 pins for this. Start index doesn't really matter again because we're going to be renaming them all anyway. I say okay. You're going to see that there's my symbol. You can left click to place it, and there we are. Okay, so very quickly you can generate a symbol this way. You can also hand draw it. This works when you're dealing with integrated circuits that don't have a standardized symbol. So basically anything that isn't an op amp or you know, a transistor, diode packages, things like that. So most ICs can be very easily done this way. So it's a good tool to be aware of. Now from the data sheet, we have to rename these to be the different functions. So what we're going to do is we're going to use a name command, which is this one right here. Okay, it'll be called VN. This one will be our set for reset. Like this. In the data sheet, it shows up as our set like this. This one will be our SNS. Okay. And then this one will be drain. And this one will be VS. Okay. Now there are a few things that I want to kind of recommend here is one, you always want to center the symbol, which is what we've been able to do here. Okay, 4 and 4, it's well centered. The reason for centering is wherever the origin is in the symbol editor, that's where the handle is going to be for the component to be manipulated and selected in the schematic. And by convention, we determine that to be the center. That way you can always just look to the center of the part and know you can grab it from there. Makes it easier to place things, to orient things. So we highly recommend you always center your parts, both in the symbol editor and in the footprint editor. Okay. Now at this point, I can move a couple of things around just because I think it'll look nicer if I have it like this. Make this a little bit shorter. I don't need such a big symbol. That'll save us some space. And I'm just using the move command here and left clicking. Okay. And this is pretty good for me. Now, a couple of things we want to highlight here. If you pick a pin, you'll see how it, whoops, had the move command active with group selected. If you pick a specific pin, you'll see its parameters here. And you're going to see that there's direction, which is very useful when it comes to the electrical rules check. Basically, Eagle checks that the pins are connected to compatible directions. So in the case of IO, there's no special checks, but according to the data sheet, VN should just be an input. Okay, and you can see this on page 3 of the data sheet. So I'll bring this up real quick so you guys can see. Right here, page 3. You'll see that VN should always be an input. So we can do that to help our electrical rules checking. So go over here. We'll make IO to just be an in. Okay. Length here is basically how long this little pin line is. You can pick middle. You can pick short. I never recommend point, but it's there, but I don't recommend using it. It can make it very hard to spot. Function, this is used mostly for digital ICs. So you can have, you know, an inverted pin, you can have a clock pin, you can have an inverted clock pin. Okay. But since we're not dealing with a digital IC in this case, we don't have to worry about that. Function, that was function. So visible, by default, it's sets to both. So what this means is that when you use this part, you'll see both its pin name and its pad number, which will appear over here. Okay. So for most cases, you'll want to leave it to the default of both. When in doubt, leave it as both. For something like a resistor, for example, you would put both of them off. You would click off and you would see neither the pad name or the pin name. So it's very clear what these do. Swap level. Now this warrants some explanation. The swap level As long as it's a non-zero, a value of 0 means that the pin is unique. It's not interchangeable with anything else. So by default, Eagle assumes everything is unique. Okay. For values greater than 0, any pins that have the same swap level number are interchangeable. So for example, if VN were 1 and RSNS were 1, then these could be swapped. That's not the case here, but I just wanted to make you guys aware of it. When it comes to the direction, the drain, according to the datasheet, is an output. So this one should also be changed. When in doubt, you can just leave it at IO. It's safe to leave it in the default IO. Okay? And this is our symbol. Now we can add a description, which is good to do. Here you can use HTML text, so any tags that you know in HTML for the most part work. So you can actually link items into the description, you can link images into the description. There's a lot of power here. Okay, so keep that in mind when you're doing documentation for your library. So at this point, I'm happy with this symbol. I'm going to go ahead and save the library, go back to the table of contents. So right now we have the symbol and we have the footprint. Now, in order to be able to share our managed library and be able to have footprints that other team members can use, then we need to turn this first into a managed library. So that's what we're going to do now. I'm going to go library, create managed library. Okay. You notice that it asks me for what managed folder do I want to use. By default, if you have no other managed folders, you're going to have one that has your username. Okay, so in my case, I have my George Garcia managed folder, and then I have access to this other managed folder that I've created and that I'm a member of. So I'm going to have this library be created in support team libs. That way other members of my team can use it. There is this checkbox here that says archive local copy on create. Now this is important. If you uncheck this box, what's going to happen is that your original library is going to be left where it is, and Eagle's going to create the managed library on the cloud. When you go into the schematic, you're going to see both, and that can be confusing. So by default, we have this checked, which will archive the library, so it won't be destroyed. The original won't be destroyed. It'll be saved in an archive location, and then Eagle will replace it basically with the managed library. So what ends up happening is this gets uploaded to the cloud, gets formatted to be able to work as a managed library, and then Eagle downloads it again. Okay? So you're not taking the original library and modifying it. You're taking it, making a copy, putting the original away, and then that copy is what's getting processed to become a managed library. So at this point, we'll just say create. It's going to go ahead and make it. Okay, and you'll see that now it is a managed library. And we can go ahead and now we can assign a 3D model. By default, you just get a block. Okay, so let's go ahead and see how we can assign a 3D model here. So as you can see, it's just a very simple block. Now, if for some reason you copy from another library and you try to modify it and you see that you can't, the issue is that you don't own the asset, and you'll see that there'll be a change here. There'll be a button here that says fork model. That'll basically make a copy into your own library, your own managed folder space. Then you can own it and you can make changes there. Okay? But for now, because I made this, I do own it, I can assign models to it. There's 3 ways to assign a model. You can generate one using the package generator, which we will show shortly. You can add a model from the built-in repo, or you can upload a step model from the manufacturer. Okay? For standard size components, for components that have an IPC standard, usually add model or generate models all you have to do. If you have a component, let's say like an inductor or a clock crystal or something like that, you may have to get the model from the manufacturer, at which point it's basically just click upload step, browse to the model you downloaded and hit open, and that'll bring it in. Okay, but for this one, let's try to use just a normal add model. So you'll notice it breaks down into my models, the ones that are in my library space, and public models. So let's see if we have a SOT23 with 5 pins on it. Okay, SOT23 with 5. I don't think any of mine are like that. Okay, so what I can do actually might be this one. Let me see. Yes. So you can see I placed it. It's a little bit off. We can go ahead and move it. Oops. I didn't want to do that. Okay. You can freehand it. Get it kind of where you need it to be. That seems roughly right to me. Yeah, it's a little low. Okay, and there we are. That looks pretty good to me. I may move it just a hair. Okay. I feel pretty good with that. There. Okay, so at this point, I have my component mapped. If sometimes you feel the board gets in the way, you can go to options and just turn off the board. Or if you want to see that everything looks the way it's supposed to. Okay, awesome. So at this point, I'll click OK. And I'll say mapped with an included model. Okay. So we say OK. And now you'll see that this will basically use the model that I created. Once I save it and push a new version to it. Now this one needs some work because if you guys look, this component has a power pad. Okay, so what we're going to do is we're going to go over very briefly how you make a power pad in Eagle. Thermal pad, this is something that comes up a lot, so it's good to be aware of it. If you go to the data sheet again, you'll see it right here, the recommended footprint size for it. Here we go. Okay, so this is what we're going to make right now. So let's go into that model very quickly. And let's fix it before we make the 3D model. Now, if you notice, you're given specific dimensions in the data sheet. Currently in Eagle, the way this works is you actually do have to do a little bit of math to calculate the pad. So what we're going to do is whenever you're dealing with thermal pads, you have to use the arbitrary pad shape feature of Eagle. If you look in the manual, you'll find more details about how this works. But basically what Eagle does in this situation is you have to provide either an SMD or a thermal or a through-hole pad to be the anchor for this custom shape. Okay, and you can have multiple pads within the polygon. As long as within the boundaries of a polygon, you have an SMD or a through-hole pad, Eagle will see the entire polygon as an extension of that pad. Okay, and that allows you to make any arbitrary shape you want. So looking at the data sheet, we're going to click on the polygon command. Okay, and the best way to go about this, in my opinion, is once you calculate your points out, then you can simply type them in and that will help you out with later steps. So in this case, we have this component that's very symmetrical because again, we're going around the center. So first thing we have to do is we know from the data sheet, and you guys can see it on the page. It is page, it's a land pattern data, but it doesn't specify which page it is. This is page 30. Okay, so page 30 of the PDF. So we know it's going to be 2.4 millimeters by 3.1. Okay, so half of 3.1 is 1.55. Okay. And then half of 2.4 is 1.2. So look what's going to happen now. Just because of symmetry. We go back to the Eagle library. Here in the command line, type 1.55, 1.2, hit enter, and you'll see that it'll start. Oh, I'm in mils. Let's switch the grid to millimeters. There we are. Always check that. Here we go. So 1.55, 1.2, hit enter, and you'll see it'll start drawing it. Okay, now we can just enter the other points. 1.55, negative 1.2. In fact, I can go all the way around now. Negative 1.55, negative 1.2. I'm just going counterclockwise. Negative 1.55, positive 1.2. And then we just close it back where we started. 1.55, 1.2. Hit enter, and you get the polygon. Okay? Awesome. This is the thermal pad for this part. Now, we obviously need this to be exposed copper, and we also need this to be to have a stencil opening. Okay? One of the caveats of doing an arbitrary pad shape is that you have to draw these features in manually. Okay, but since we typed in the points, this can actually be very easy. So let me show you on the data sheet. Okay, you can see stencil opening 3.1 by 2.4. Stop mask opening needs to be 3.1 by 2.4 as well. Okay, so this is going to be very simple. So we go over here. We're still in the polygon command. We switch to T-stop, which is the top stop mask. Okay, we go over here. The command line keeps history, so you can go up and down. So you got this one, and all I'm going to do is just add in that point since I didn't do it the first time. So you have 5 points because you have to go in a circle. You have to end where you started. I hit enter, and we have that one. And now for the stencil, which is another T cream, you go over here, hit up, hit enter, and there we go. Okay, so now we have a stop mask opening for this pad, and we have a stencil opening for this pad as well. Okay, so at this point, we have our thermal pad as intended. So now what we need to do is bring in the thermal vias. Now the thermal vias, we're told from the data sheet that they are 0.33 millimeters. Okay, now I'll put circular. Let's see how small I can get these. Okay, we'll start there. And then we're actually going to talk about a very important consideration here. So these we know are spaced 1.3 millimeters in both the X and Y directions, starting from the center. Okay, so again, since we're doing symmetry, 1.3 divided by 2 is 0.65. Okay, so we go into here. We're going to put 2 of them. So we know they have to be at the origin. Negative 0.65. And then 0, positive 0.65. Because again, symmetry, we have everything centered. There. Okay. Now we do the others. Again, I can press up. These will be at 1.3. Okay, awesome. And then the last two will be at negative. Excellent. And And obviously the thickness of the annular ring isn't very critical. Doesn't really matter because it's all part of this plane. And again, if we look at the data sheet, we'll be able to confirm that this looks about right. Okay, so we know we haven't made any serious mistakes. Now, one thing that will almost inevitably come up here is when you bring this into the design, it's more than likely that your annular ring settings are going to require a larger diameter than what I specified here. So what you'll do is you'll see these balloon. They'll swell up. The key thing is you don't want them to go past the pad itself. Okay, so to give you an idea what's going to happen is if I click on this one, you'll see that I set the diameter to this. If I set it to auto, which is what the default DRC would have it at, they'll inflate to this. Okay, so you may determine that this is acceptable, but if it's not, you're going to have to find a way to shrink it. Okay, so at this point, see that's probably as big as you could get away with right there, 0.6096. So just keep that in mind. When they swell on the board, you'll have to adjust your annular rings in order for them not to go past the edge of the pad. Sometimes it's okay if they pass it a little bit, but most of the time you're not going to want them to pass it at all. So keep that in mind. Okay, so at this point we've created our thermal pad with our thermal vias. And when we go to make the device, we'll see the importance of connecting these properly. Okay, so we'll go into that in a moment. Let's go ahead and find a 3D model for this part. So I'm going to go ahead and save. You'll see once I save, I have new local changes. I need to push those to the cloud in order to keep everything up to date. We'll go over here, and now let's go ahead and fix this 3D model. Oh, wants me to make the new version first. Create new version. You'll see the version will grow. Whenever you see a version number plus edits, that means you have local changes that you haven't pushed up to the cloud. You always want to keep them in sync. You don't want to have a whole ton of local changes, but never update the version on the cloud. So you want to keep them in lockstep. So go over here. Okay, we can see. Again, we get the block. For this one, we're going to use generate model. And you'll see these are all the different types of packages that we can create models for. So in our case, we're interested in an SOIC part. Okay. Here we have all the dimensions we need to provide. And we can get this just by comparing what's here with the data sheet. Now, word of advice, don't assume that the letters here match what's on the data sheet. Sometimes they do, sometimes they don't. So you have to be extra careful. Okay. In this data sheet, for example, by TI, they don't even use the letter system. Okay. So keep that in mind. So here we're going to see what dimensions we need, and we're just going to put them in to the managed library here. So we have a lower case E, that's the pin pitch. That should be 1.27. There it is, 1.27. It's happy, so we're good there. This large E is the limits including the pads. So we go back. Limits including the pads. So here we would have to do a little bit of math. Let me see if the one before has it. Yes, right here. Okay, so limits including the path. 5.8 minimum, 6.2 maximum. So we go back to Eagle. 5.8, 6.2. Okay, L, we have this little L part here that it wants. We go back, we look, L 0.4 to 1.27. That's what we have here, nice. B, the thickness of the actual pins themselves. 0.31, 0.51. make it match. Okay, number of pins is just 8. D, which is this overall length here, 4.85, 4.8 being minimum, 5 being maximum. Okay, E1 is the actual body thickness itself, 3.8 and 4. Okay, we have this A, which is the height, and A1, which is this little height here. So A height is 1.7 max, and then this little part here would be 0 to 0.15. That was 1.7, I think. Okay. Yes, 1.7. So then obviously we have not defined the thermal pad, which we'll do now. D2, we know that from the data sheet to be 3.1. And we know this to be 2.4. We update the preview. Okay, that looks better. Let's go ahead and turn off the board again. Now we can see more clearly what we're dealing with. Okay, that looks good. We see the thermal vias pop through. We see the body in okay. This is where pin 1 should be. So there's our pin 1 marker. So this looks good. Okay. So at this point, we say okay. Created with package generator. You always want to put something in the description. It doesn't have to be what I'm putting in per se, but it's good to have a paper trail of all the changes, everything that you've made, etc. So I'm going to keep this. Now, one thing to keep in mind, if you want to preserve the name of a 3D package, you have to first have the footprint. Okay, if you go straight to the package generator and you just make a footprint, I'm sorry, if you just make a 3D package off of that, you're going to get the IPC name with all the long string of characters and things like that. And these can't be renamed. 3D packages are not allowed to be renamed. So keep that in mind. So at this point, we have our two components. I'm going to go ahead and save. We're going to create a new version just so that everything is up to date. Okay, nice. See if things show up updated. They do. This one still doesn't, but that happens sometimes. This indicates being processed. So last thing we have to do is just make a device.
Hey, George, just to let you know, I'm stepping out. I got to go somewhere.
Sounds good. So at this point, we're going to make a device. We're going to name it TPS 92411. Say okay, say yes. Now device basically is the marriage of everything we've already done so far. It takes the footprint, which is linked to the 3D package, and marries it to the symbol. Okay, it's the mapping of one to the other. And when you're working in a schematic, you're bringing in devices. This is what you're bringing in when you make a schematic. Okay, so very simply, first thing we're going to do is we can add in our symbol. Again, Always recommend to center it if possible. If you have a multi-gated part, you can put it anywhere. But again, just a convention to keep everything on the center if possible. Okay, next we're going to put in a prefix. Prefix is what will show up in this $1 space. So every time you bring in this component, it'll have this prefix and a number. I tend to like IC. So this will be IC1, IC2, IC3 for as many of these as I bring into the design. Value off versus on warrants some explanation. If value is set to off, then by default, this field is not editable, and its value is actually the name of the device. So you can see that for integrated circuits and things like that, off is usually the preferred option. If you have a passive or something where the value is going to be changing depending on the use or where it shows up, then you're going to want to have value on. On means that by default the value is empty and it is editable by default. Okay, so for this application, I want to set to off. Now we're going to bring in the footprints and the 3D packages. So we click on new. I'm going to say add local. I'll pick this one to start. Notice that variant name is empty. Okay, and this is something that crops up often. If you're only assigning one footprint, you never have to worry about this. The second you're going to assign another one, then it becomes important. And you'll see why now. So we're assigning our first. It goes off without a hitch. Everything looks good. Now we're going to assign our second one. And you'll see package variant is already defined. If you don't put in a name, it gets this two single quotes. Okay. But that can only be used once. You can't have multiple packages with the same variant name. So now we have to enter a letter or a name. So in the case of the SOT 23 on the data sheet, it's DBV. That's the definer for it. So DBV. There we go. And I can actually rename this one to be what the datasheet says for it as well. So I'll put rename. This one will be DDA, which is what the datasheet has. Okay, let me show you guys where that is. And you'll see it, it gets tacked on to the name of the part. So it's good to name these properly. If we go over here, DDA and DBV. Okay, so that's where that's coming from. So at this point, we're going to go ahead and now map them. So we go to connect. Okay, and you're going to see that in this footprint, if we look at the data sheet, it says the thermal pad should be connected to the VS pin directly beneath the device. Okay, so what we'll do is when we make this VS connection, we know VS is pin on the DDA, it's pin 4. Okay, so we'll link it to pin 4, and then we can append all the thermal pads, which are these here. And you'll see they're all right here being connected. Okay. And then for the others, drain in this footprint is pin 8. Our set is pin 3. Our SNS is pin 5. And then VN is pin 1. Okay, so pins 2, 6, and 7 are no connect, and we look at the data sheet and they are not. So that's okay. So one thing I want to highlight here, okay, if you notice this icon here is very important whenever you have multiple pads assigned to a single pin. By default, it has this function called all, which means they all have to be connected. They're all going to get an air wire in order for the netlist to be satisfied. If you switch it and you have it like this, you're going to have any, which means as long as any one of them is connected, then the whole netlist is satisfied. In most cases, you would probably, for something like this, you would use any. But the problem in this particular case is that the thermal pad needs to touch pin 4. Okay, so if we have it like this, it can lull you into a false sense of security, because if you route to just pin 4, 4 is one of these 7 connections, and it'll be satisfied, but you won't have a connection to the thermal pad. Okay, So the safest approach here is to set this as all, which is how it is now, and then just deal with the extra air wires that are going to crop up. Okay. Another option would be to maybe make it its own pin. That's another option that you could roll with as well. It's always okay to have leftover pads. You're never allowed to have leftover pins. All the pins must be used. It's okay to have some leftover pads, and that's what we have here. So I'll say okay. You'll see that we get a check mark, meaning it's been mapped. Now we'll do this one. I just double clicked on it. Again, we go to datasheet. Drain is pin 4. We hit connect. Our set is pin 1. Our SNS is pin 5. VN is pin 3. And VS is pin 2.
Now that the meeting is done, now we can say bye. Hey, Joe.
Okay, awesome. And then finally here's where I would put something. So I'll put in bold TPS 4211. One day we'll make this WYSIWYG, and that way you don't have to know the HTML tags off the top of your head. Okay. Offline LED driver. And then, like I said, we can link it. So I'll go over here, just link it to this data sheet, Control C. Control V to paste the whole link. Close the double quotes, data sheet, and then close the tag. Say OK. And you'll see that now we have this. I'll save it. I'll create a new version. And now everything is up to date. Okay, so at this point we have a managed library. It's part of our support team libs manage folder. Let me show you guys how you can manage it. Managing the folder is actually done through library.io. It's not, you can do certain things in Eagle, but it's really managed through library.io. So let's go to the control panel so you guys can see. If you notice here, these are my libraries. Any managed folders that I'm a member of will show up here, but the libraries that are in them don't automatically show up, okay? Because Eagle isn't just going to download possibly hundreds of thousands of libraries that you're only interested in one or two. So in this case, because I made mine, it's there, you know, the sharing managed library, it's right here under support team libs. Other members of your team that have access to this managed folder would see it in the same way here once they download the library. So if they haven't downloaded the library, what they would have to do is you would just open up a design, go to options, library, open library manager, and it would show up under available. Okay, they could just sort it by the managed folder. So it would go through, find the managed folder, support team libs, and any libraries that are available that they haven't downloaded would show up here. Okay, and they would just grab it from there, hit use. At that point, it would show up in the control panel, just like these do. Okay. So really, really important, really, really useful to be aware of. This is how it works from within Eagle. Now to invite people to use your library, just click on library.io. Okay, you'll be taken here. This is your hubs. Now you'll notice that it defaults as a support team libs manage folder that I'm a part of. I can switch to my own and see my own libraries. Okay. You can delete libraries, manage folders. They can be deleted and everything that goes with them. If you want to add people, you can click right here. You can just enter email, send it off. And then once they accept, they're part of the They're part of the members that can modify and adjust. So you can either have an owner role or a contributor role. We don't currently have anything less than that, although we are working on it. Okay, so here I have my own. I'm the owner of it. You can transfer ownership if you wish. You can change the name of the folder. You can make other adjustments like that. Okay, so keep that in mind. If you're on a free, if you're using Eagle Free, I believe you only can own one managed folder, which is the one that's your named folder, but you can be a member of as many folders as you're invited to. Okay. If you're a corporation, then you obviously have access to making more managed folders and managing them. Okay, so this is basically what we wanted to cover today. Let me go ahead and stop the screen share so we can answer some questions if there are any. Let me check the YouTube also if we have any questions there. Okay, so we have no questions on the managed folders or anything else, even on the YouTube. So thank you everyone for joining us today and for being part of this webinar. As always, feel free to reach out if you have any questions. I'll go ahead and put in our support email in the chat. Okay, and thank you very much, everyone. Have a great day.